Well, hello there. This is going to be part two in the video series on getting a board manufactured using the JLCPCB pick and place capability. As I said in video one, I've never done this before, so this is a complete learning experience for me. So over here, you're looking, whoops. I didn't mean to do that. There you go. You're looking at the board that we plan to have manufactured. After the video the other day, I added some identification stuff to the board and brought in a little icon that I made up in Inkscape just to have something to identify the board. Obviously, this isn't necessary when you're doing a board, but I thought I'd have some fun. I have also renamed the file version 1.0 so that I would have some version control on this. So if this version doesn't work and we want to do a version 1.1 or something like that, I'll at least have some control on the files. But other than that, it's the exact same file that we ended up with the other day. So let's go over and take a look at the JLCPCB website. And down here at the bottom, they talk about their SMT assembly, which starts at $7. Now, I don't know what that means. I don't know how it changes. If you click on this location, they talk about some of the stuff they need, and they talk about their parts library. So I wanted to talk just a little bit about this parts library because it's really interesting. They have two kinds of parts. They have basic parts and extended parts. And the basic parts, there's basically not a setup fee to use those parts. I guess they're always loaded on the pick and place machine. But if you get one of the extended parts, I guess somebody has to manually grab a reel from the library and stick it into the machine and align it or something. So they charge like $3 a component for the extended components. That's still not much, but it could add up if you had 20 or 30 extended parts on there. So when you look at their library, they categorize them in basic configurations of things. So like we're going to be using LEDs, and they have opticouplers and LEDs right here. So I can click on that, and they talk about, let's see here, light emitting diodes. They have 107 light emitting diodes. So if you click on that, you'll get a list of all the different light emitting diodes they have. And you can see right here, it says that this section right here, 1, 2, 3, 4, 5, 6, 7, 8, 9 parts right here are basic parts, and then there's an extended part. And I think all the rest of the parts are going to be extended parts. So those few basic parts at the beginning are the only basic LEDs they have. So let's see what they have available in those basic LEDs that we might be able to use. So remember, we're looking for red and yellow LEDs that are 0805. I wonder if I can do a search in here for 0805 and get it to actually LEDs 0805. Let me just click on that, and maybe that'll. Oh, that's all. Let me go back to LEDs. As you can see, I have no idea what I'm doing here. Okay, so there, right here, there must be something clickable here. Okay, there you go. So there is a LED 0805. It's red, and it cost about 2 cents a piece. 0.019. Over 200, it's 0.008. We're only going to be needing 150, so we're not. Actually, we got 150 per board, 5 boards. Yeah, so the price will drop down to less than a penny a piece for those LEDs. So that's a potential option there. What is this one? That's an 0603. I want 0805s. Okay, so here's a yellow one. And there's a yellow 0805. So they have a red and a yellow 0805 LED. I'm not exactly sure what color of yellow or what color of red it is, but we're probably going to use those too because those are completely capable units. So I don't have anything to write with in front of me right now. So I'll come back to here and get a piece of paper and write down these numbers so we can use them later, because we're going to need to identify what parts we want to put in our unit. So let me pause the video, I'll get a piece of paper, and I'll be right back. Okay, so I believe that the only number that we have to be concerned about is this LCSC part number, because that's what they use. So this is the yellow LED, and it is C2296. Okay, let's go back up to that red. I think it was this one. No. This one. Okay, this is a red 0805. And that number is C84256. So while we're doing this, we might as well go ahead and look for the 2 resistors also. So let me pop back here and look at, you must have resistors here somewhere. Oh, there you are, right, first thing, resistors. Chip resistor surface mount, I imagine that's what we need. And I'm going to guess that they have a ton of basic parts here because they probably have one in every size. So I'm just going to step through here, but yeah, they got a whole bunch. So we need 100 ohm. Let me see if I can find that. 100 OHM. Okay, in the basic parts, there's a 100 ohm 1206. We want 0805s. There's a 100 ohm 1%, 1th watt. Yep. Okay, so and again, these are 0.002, 0.003. We're not going to use 1,000 of them, so it'll be 0.003 cents for those. But the 100 ohm is part number C17408. And the other thing we need is a 470 ohm resistor. 470. Basic parts 470. Let's try that one. Nope. This one. Oh, 402. Tiny. 603. Person. Okay, there you go. So again, it's 1/8 watt, 0805, and its number is C17710. So those are all the parts. Those 4 parts are the only parts on this board. The connectors aren't surface mount, so those will have to be hand soldered in after we get the boards built. But that should be all the parts that we need. So now let's go back. How many times I have to step back up. I was looking through here, and they tell you what the files that you need. Okay, what files are required? And if you pop under there, apparently you need a bill of materials and a component placement list. So I'm going to click on these, and I believe it will download a copy as an Excel file. So as soon as that gets downloaded, I'll open it up. Okay, so very simple file, component size, the designator in the in your schematic or your layout, what footprint you need for it, and what the LCSC part number is. Now, the first 3 items should be provided by the KiCad programs file producer, and the last one we'll have to hand edit in. There's probably some way to embed that information into when I built the schematic, but I didn't do that, so I'll manually edit it into the file. But it looks like they just have one row for each type of part, and then under that row they put all of the numbers comma separated. Now this is kind of interesting. This one they have C2, C9, and C10 with commas, and here they just have a C3 through 5. So it looks like I could say, you know, if my numbers were sequential, which they aren't, but if the first 150 were the red and the second 150 were the yellow, I could just say, you know, 0 through 149 is red, and 150 through 290, whatever. But I can't do that because I think they're going to alternate around. So, so that's a nice look. So that's one file that we'll have to create, and then they have a placement. So let's look at that. And again, they list each of the components and the center X and the center Y position, what layer it's on. Now I know it says in their documentation that they'll only place parts on one side, top or bottom. So in this particular case, the fact that they said that R2 is on the bottom basically says that they're not going to place it. And then it also lists the rotation of the part. I'm assuming that the files that KiCad will produce will show you, will give you all of that information. So let's go back to the KiCad program. I'm gonna close this pretty view and go back to the layout view, the board view, and under the PCB News menu under Files, there's a Fabrication Output, and it'll produce like your drill file and stuff, but it will also do a footprint report and a BOM file. So let's do the BOM first, and comma separated value is the only possibility, but Excel should be able to read that. So I'm going to put this up at the top of my thing, and you can see I've already done this once, but so I'll save that BOM. And now I'll go open that file. Okay. Now, if you look at this file, it kind of sort of looks right, but not. I mean, it seems to have information here, but it's all squirrely. And I can see that up here on the top, it has designator, package, quantity, supplier, ref, and I see that there's semicolons in here, and also down in here there's semicolons. So it looks like they didn't really use a comma separated value file. They actually did a semicolon separated file. So Excel can bring in other orientations, but if it's named CSV, it'll bring it in just as a CSV file. And it'll assume commas because CSV stands for comma separated values. So I'm not going to save anything. I'm going to go back to my Miss Pacman directory, and whoops, go up one, put it up at the top, date modified. Okay, I'm going to take this file, and instead of calling it comma separated value, I'm going to call it text. And then let me see if I can just say open with Excel. Okay. Let me just start Excel and open it. Okay. So I'll open that, and delimited, semicolons. I think I'll do it. Okay, much better. Okay, let me just word wrap this. Okay. So what have we got here? We got, that's my icon. When you put an icon on in a file, it actually makes it a footprint, but obviously there's no part associated with it. So I'm just going to delete that. I'm also going to delete J1 and J2 since they're not going to be placed. Actually, let me delete the whole lines. Okay, so then we have our resistors. 0805 footprint, all those resistors, quantity 50, designation. I don't remember if there was a quantity field. I'll have to look back on that. Does it, I think this needs to say 470 ohm. I think there's said ohm in it. I will validate that. Actually, it's not going to make any difference because the supplier number is the thing that's gonna identify these things. So the 470 ohm resistor was C17710. I'm gonna go ahead and put the rest of the numbers in. You don't need to watch that. I'll be back in a second. Okay, I have those four designators that I copied down earlier typed in here. I did put the designators back because I think those are the designators in the schematic and they probably need to be exactly what they were. So I put them back to just 470 and 101. The yellow LEDs are called LED underscore Ys and the red LEDs are called LED underscore R. So that is the designators as they're listed on the schematics. The quantities, the packages, and the numbers, and I think those are all the information they needed. I will validate against their exact format to make sure that the columns are in the same place, they're named the same way. I don't know if that's important or not, but it will just take a couple of seconds to make it match up, and then I'll have that file done. So let me save this. Let me Okay, so that file is saved. Now let's go see about getting the other file. Okay, another CSV file. What do you want to bet it's got the same layout as the other ones? And okay, doesn't seem to have any data in it. Let's change that to text. Okay, it seems to have all the right names, but it just doesn't seem to have any data in it. I wonder if you have to select them before you can generate the report. Let me go back to here. Select all those. Okay, so now it said that it had 450 components, so that sounds good. I don't think I need that. Go back over here. Oh, wait a minute. See what I did? You guys may have noticed this. there's two files, a bottom and a top, and I opened the bottom file. I needed to open the top file because all my components are on the top. Notice the difference in size, 1K, 330K. So this one, now let's just double click it and see if it opens as a CSV file. And actually that looks like a good CSV file. I'd have to validate that these are the exact center positions. I've actually done that already, and it does catch the center of the thing. So if I go to my drawing and go to the center of diode 0, you'll see that 96.92 and minus 96.5 is the center of that diode, that LED. Rotation 270. Now that looks right. 4210, yeah. So here are the resistors. So it looks like this file is created pretty flawlessly, all by without. Doesn't look like it's going to need any editing or any additions to it. So you'll remember that the file they had a layer column with a top and a bottom layer on it, and this one puts the tops in one file and the bottoms in another. But again, since they're only going to do one layer, all I have to do is add a column to this that says side. And actually, it's got the column says side, and it all says top. So this file is done. Okay, so I will resave that. Okay. So the other things we need to do, of course, is we need to generate the Gerbers. The Gerbers are generated by the plot function. So you have to go file plot, and you pick Gerber from the plot format. You pick which layers you want. So front and back copper, front paste maybe, I don't know. Front silk, back silk, I don't have any back silk. Front mask, back mask, cut edge. That should do it for that. Plot footprint values. I don't need to plot the values, just I don't even actually have values, just the references will be fine. I didn't place the values like yellow and red LED, but they're going to place everything for me, so it's not important to have that information there. Pads from silk. That's new. I don't remember seeing that before, but I think we'll do that. So we'll go ahead and plot those. And we'll generate a drill file. I think I always just kept the defaults on that, so. And I think that's all we need, I think. So the next step is going to be to take those two files that I generated for the placement and BOM and make them exactly like the one that I downloaded from JLCPCB. I'm not going to film that. It's just editing the titles and putting the columns in the same order and stuff like that. So I'll bring you guys back when I get that done, and I'll show you the finished product of those two things. So I've just finished doing the component placement mapping. There was actually some extra columns that KiCad gave me that weren't needed, and I deleted those. I put these things in the same order. I actually copied their header and tossed it in mine. One of the things I've noticed, and this is something I just recently learned about KiCad, I don't know that it makes any difference at all. I certainly hope it doesn't. But their XY coordinate system, their Y is inverted from what I would expect it to be. They use what they call a screen-oriented coordinate system. So the upper left corner or the center of the XY is 0, 0. And as you go to the right, the X increases in the positive direction. As you go down, the Y increases in the positive direction. If you go up above that, Y becomes negative. So when you draw in what would normally be the positive upper right quadrant of a drawing, the Y items are negative and they get more negative as you go up instead of more positive. Now, I've ordered boards manufactured by JLCPCB with the KiCad BOMs just directly output, and I've never had to worry about that before. So I assume they somehow understand that and do the flipping or the orienting it correctly, or somewhere in there there's something that explains that to the software that they're using this kind of orientation system. But it was really confusing to me when I first came across it. And that was back before I learned about all of these neat macros, and I was trying to hand place my components, and the negativeness just really messed me up. So anyway, I just thought I would point that out. I'm going to leave it just like it is and order the board that way, and we'll see how it turns out. Okay, under my current active folder, the version 1.0 folder, I placed a directory called orders, and in that directory, I put all of the Gerbers, the drill file, and the bill of materials and the pick and place list. And then I made a zip folder of all of those so that they are ready to upload, because when you upload something to JLCPCB, it has to be in zip or tar format. So I have this folder ready to upload that I think has everything I need in it. So I'm just moving this to my other screen while I bring up the JLCPCB thing. I'll hit get quote. And this is a first for me, so I'm not sure. I mean, I've done quotes for just straight boards, but oops. Orders, zip file. Okay, the board looks good. So the board cost is going to be about $15.60. Want to do assembly. Okay, so the basic cost of that is that, but I don't know how you get the parts cost in here. So there's a big next button here, so I guess I should click that to see what it does. Add a BOM file. Okay. So it looks like those don't get included in the zip file. Um, they get sent out directly. So there's the BOM file. And a CPL file. Okay. Okay, so it looked at all my parts and it gave the parts list and the cost and asked me to confirm that. So there is the cost. Um, they added the cost for all those parts. Um, engineering fee, the components are $13.22. They're only charging me $6.78 for the assembly of 5 boards. Um, and the total cost comes to 42.60 now. Shipping probably went up a little bit because that probably added a little weight to it. Let me hit save to cart and see if it gives me a shipping cost so you guys have an understanding of this. I am not going to order this today, just in case you guys are wondering, because I want to build a prototype of this and test it out before I actually place the order. So I'm just going through the steps of what it would take to actually do this order. And so I still don't see, it doesn't look like I can get to shipping cost without going through the checkout procedure. So I'm going to stop here. Before I added the parts, it was $18.20 or something like that for shipping. I'm going to think it's going to be under $25. So let's say under $70 for 5 boards. So that's amazing. It's just absolutely amazing that you can have a board manufactured in a couple of days and shipped to you for under $100. I mean, it's like under 20 bucks a board. It's just amazing. Anyway, I hope you enjoyed this. I might do a little follow-up when we actually order the boards, but I thought this would be interesting to some of you guys. And it was certainly a learning experience for me. Thanks a lot for watching, and hopefully soon we'll be ordering this board and you can see if it works or not. Thanks a lot.